Hello, in this video I will demonstrate how Parasoft C++ test integrates into Microsoft Azure DevOps CI/CD pipelines. We're going to see how easy it is to create an Azure DevOps pipeline with C++ test static analysis, how to access static analysis results in Azure pipelines, and how to download results from Azure DevOps to Visual Studio Code for convenient remediation. For the demonstration, we'll need an Azure account with a repository for the demo project, a Linux workstation with Parasoft C++ test, GNU GCC compiler, and Visual Studio Code, an Azure agent for executing build and test pipelines, which we will set up on the workstation. During the demonstration, we'll go through the following steps: creating a demo repository in Azure DevOps and adding an example project to it, preparing and configuring the Azure agent for build and code scans, defining the pipeline with C++ test static analysis, and with all this in place, we'll simulate a simple use case. A developer will pull the code, introduce changes using the VS Code editor, and push the code back to the repository. The push operation will trigger the pipeline, which will launch C++ test to perform static analysis. Static analysis results will be published and available in Azure DevOps for inspection and downloading to the local developer desktop. So let's start with creating a new repository for our demo project. I will switch to my Linux environment. Now I will open the browser and create a new demo project. I will call it Azure Integration Demo. Now let's initialize the repository and add some source code. We'll use the popular timer example project shipped with C++ test. In the home directory, we have C++ test installed. Let me go inside and switch to examples/timer directory, where we have our example source code. This is a simple project we'll be using for the demonstration. Let's add this source code to the repository we've just created and commit. Great! Now we have some source code in the repository. We're ready to start development. The next thing we want to do is to configure the pipeline, which requires configuring the Azure agent. We'll use our demo machine as an Azure agent. Let's go up and select Azure Organization Settings, then Agent Pools. Here I will select Self-hosted CPP test. This is the pool I've previously added to my organization. There are no agents assigned to it yet. So let's select New Agent and then Linux. What we got here is a collection of commands for downloading and configuring the agent. So let's first download the package. Now I will open a terminal to execute the commands. First, we need to create a dedicated directory and unpack the downloaded package. We are almost there. Now we need to configure the agent. We need to provide server URL and authenticate. I will copy the authentication token in the background and paste it here. Let's name our agent Demo Agent and proceed with the default settings. It is now configured and we are ready to run it. Great, our agent is up waiting for jobs and we are ready to define our pipeline. Let's move back to our project in Azure to set up a pipeline with C++ test static analysis. We need to click on Pipelines and then select Create Pipeline. Here we select our repository location and then select the actual repository for which we want to define the pipeline. In the next step, let's select the starter pipeline. We'll use it as a base. Pipeline for Azure DevOps are configured in YAML files, and now our YAML file is ready for edits. Let's expand the Tasks Assistant, type Parasoft, and select the Run Parasoft C++ Test task. The C++ test extension for Azure simplifies configuring the pipelines for static analysis. Instead of constructing the command lines manually, we can simply provide values for the most important parameters, and the task will take care of the rest. Let's click the info icon to see more information. Here you can view the complete documentation for the C++ test extension for Azure DevOps. It includes examples of the pipelines with static analysis. Let's copy the pipeline definition from the example here and go back to our new pipeline and simply paste it. Before we save our pipeline, let's take a quick look. The pipeline is pre-configured to run for main or master branch. We can modify it to be also applicable for feature branches. As you can see, the pipeline is configured to run on self-hosted runners. It uses CMake to build the code. Here we're telling CMake to generate a compile commands.json file, which will be used as an input for C++ test static analysis. Once the code is built, code analysis is executed with the run cpp test action. The action takes the compile commands.json file generated by CMake and executes static analysis. There are a couple of options that can be modified here. You can find more details in the task description. We'll use the default values for our demonstration, which means that the source code will be scanned with the pre-selected collection of static analysis checkers called recommended rules. Once the code is analyzed, C++ test will generate a SARIF report which will be uploaded to Azure DevOps. The results included in the report will be presented in the Scans tab. We are ready to commit our pipeline now. Let's add a short comment and commit the file. The commit immediately triggered the pipeline. Here, the clock icon next to the job indicates that our pipeline is already in progress. And now let's take a closer look. Here we can see the steps in the pipeline being executed on the agent, including static analysis with C++ test. When the pipeline completes, the SARIF report is uploaded to Azure DevOps and the results are presented in the Pipeline Scans tab. Let's drill down and take a quick look. Here we see a summary showing the total number of violations and the number of findings reported for each individual rule. If we expand the category, we'll get more information about each individual finding. Here we have a violation of the rule avoid accessing arrays out of bounds. As you can see, the violation is presented with snippets of code and additional annotations which help with understanding the root cause of the problem. When we click the violation, we are taken directly to the source code editor where we can view it in context. C++ test integration with Azure provides a great value here. The ability to review code scanning results directly in Azure DevOps, either in the context of a specific check-in or as a part of a pull request, streamlines the development workflows and reduces the cost of the compliance process with industry standards. Now, let's see C++ test Azure DevOps integration from the perspective of developer activities. For this, I will clone the repository to my local workstation. For development, we'll use Visual Studio Code. So we will clone the repository using VS Code. Let me switch to the repository view. Now we need to select the location of the repository and enter the credentials. We have successfully cloned the repository, so we can open it in the VS Code. The first thing we can do is to download the latest static analysis results generated by Azure DevOps Pipeline. Let's use the action provided by the C++ test extension for VS Code to access the results from the latest pipeline. You may be asked to sign in to Azure, but I'm already authenticated. And as we can see, all the results we could previously see in the Azure pipeline are now downloaded to the VS Code. The C++ test extension automatically identified the latest results for our current branch. If we have multiple pipelines with static analysis, we'll be given a choice from which pipeline we want to download results. This functionality is a great help and a time saver for developers. They are more productive when they can review and remediate bigger batches of static analysis violations generated in Azure pipelines without leaving their preferred IDE. So let's try to actually fix one of the problems. Here we have a violation of "do not check for null after the referencing" static analysis rule. This is an easy fix. Here we have another violation, which we want to accept for now. So I can suppress it. Now I will commit my changes and push them to the upstream repository. Naturally, it will trigger the pipeline. Initially, there were 5 findings. Now we expect 3 problems to be reported, because we addressed one finding and one was suppressed. If we go now to Azure DevOps, we can see that the pipeline is in progress. Let's give it a second. It finished. We can check the code scanning alerts now. As we expected, there are 3 violations only. Great! This simple use case presents the typical actions performed by developers when working with Azure DevOps. In the real life, the development process is likely to be more complex, with a large number of feature branches and pull requests. C++ Test Azure DevOps integration is proven to support advanced development models. And this concludes my demonstration. Let's quickly recap what we have covered. We have discussed the procedure of creating an Azure DevOps pipeline integrated with Parasoft C++ Test static analysis. We've seen how static analysis results are presented in the Azure DevOps interface. And we've also seen how developers can utilize the C++ Test VS Code extension and the Azure DevOps integration to streamline their daily activities. Thank you for watching.